All right, so get this. Remember that crazy solar storm back in May 2024?
Oh, yeah.
Well, turns out it did more than just give us some pretty auroras, you know?
Right.
We're talking a full-on cosmic makeover. Earth's got like two brand new radiation belts.
Wow.
I know, crazy, right? And today, we're going to dive deep into the science of all this.
Sounds good.
We've got reports from NASA, Live Science, even LASP, a whole bunch of sources.
Okay.
So buckle up, because things are about to get really interesting.
The solar storm was, it was the strongest we've seen in like over 2 decades.
Yeah.
It really fundamentally changed the way Earth's magnetic field is structured. It's fascinating.
Okay, so for those of us who haven't, cracked open an astrophysics textbook lately, can you break down what actually happens during a geomagnetic storm like this one?
Sure. Imagine the sun just like throwing a massive temper tantrum.
Okay.
And it just spews out all these charged particles.
Yeah.
And when these particles hit Earth's magnetic field, it causes like all kinds of disruptions.
Oh, wow.
I mean, we're talking auroras that are visible way further south than usual, and you get disruptions to GPS systems.
Oh, yeah, for sure. I remember my GPS, taking me in circles during a really bad storm once.
Happens to the best of us.
But okay, getting back to these new radiation belts, where did they even pop up? We already have the Van Allen belts, right?
You got it. So picture Earth with these 2 donut-shaped rings of energetic particles around it. Those are the Van Allen belts.
Right.
And what happened in May is that 2 new belts formed, like right between the existing ones, like a cosmic sandwich.
A cosmic sandwich, I love that. And these weren't just faint traces, were they? What kind of particles are we talking? And how strong were they?
No, these were the real deal.
Okay.
One of the new belts was just packed with electrons.
Wow.
They had 1.3 to 5 MeV of energy, and it was located between 2.5 and 3.5 Earth radii from the center of our planet.
So, that's way out there.
It is. To put it in perspective, imagine the distance from Earth's core to the surface, and then multiply that by 2.5 to 3.5.
Oh, wow.
That's where this belt was hanging out.
Okay, that's pretty far out. And what about the other belt? What was that one made of?
The second belt was even more of a surprise, actually. A proton belt.
Okay.
It was crammed with protons carrying 6.8 to 20 MeV of energy in the same general area.
Hold on, a proton belt, that's not normal, right? I thought these temporary radiation belts were always electron things.
Yeah, you're right. It is unusual. And that's what makes this discovery so interesting.
Yeah.
Usually these temporary belts, they form and vanish within a few weeks, mostly made up of electrons, and we get how they work.
Right.
But this one, this proton belt, stuck around way longer than anyone expected.
Oh, really?
Instead of disappearing in a few weeks, this thing hung around for months.
Wow.
It's a real head scratcher.
Yeah.
Challenges our current models of how radiation belts form and behave. Suggests that extreme solar events like this can have much longer lasting and way more complex effects than we originally thought.
That's a pretty big deal. If our models are off, how can we know what these solar storms are going to do? And how did we even find out about this proton belt in the first place?
Well, it's kind of a cosmic coincidence, actually.
Oh.
So the CRBE satellite stands for the Colorado Inner Radiation Belt Experiment.
Okay.
It had been offline for a few months because of some technical problems.
Oh, talk about bad timing.
Yeah, it was like someone hit the snooze button right before the main event.
Oh, wow. But I'm guessing it eventually came back online.
It did. Luckily for us, CRI was back in action just in time to catch the aftermath of the solar storm, including the formation of these new radiation belts.
So the CRB satellite, what makes it so special? I mean, was it just in the right place at the right time, or is there something more to it?
It was definitely in the right place, but it also has some pretty amazing tech on board. CRB carries an instrument called Reptile 2, and it's incredible at measuring radiation.
Really?
It's super precise, and it can differentiate between all sorts of different types of radiation and their energy levels.
So it's Reptile 2 is like a super-powered radiation detector.
Pretty much.
And without it, we might have missed this whole thing.
Exactly. Reptile 2 was key to this discovery. And it shows how important it is to have the right tools in space to observe and understand these events.
Okay, this is all incredibly cool, but I gotta ask.
Yeah.
Why should we down here on Earth care about some extra radiation belts way up in space?
Right.
I mean, it's not like we're planning on, taking a weekend trip out there, right?
That's a great question. And the answer is that this discovery actually has some very real implications for us here on Earth.
Really?
Think about all the technology we use that's up in space, like all the satellites for communication and navigation.
Right. So you're saying this new radiation belt could actually cause problems for our satellites.
Yeah, it's definitely a concern.
Okay.
These high-energy particles, they can damage sensitive electronics, causing glitches, data corruption, even complete system failures.
And that's all pretty bad, especially when you think about how much we depend on those satellites. I mean, for everything from GPS to, streaming our favorite shows. What else should we be worried about?
Well, it's not just about our tech either.
Okay.
This discovery also impacts human spaceflight, especially as we think about venturing beyond low Earth orbit. Think about that upcoming lunar base everyone's talking about.
Right, so you're saying this new radiation belt could be a health risk for astronauts.
That's right. Increased radiation exposure is a big concern for astronauts, especially during those longer missions.
Yeah.
It could really increase the risks of radiation sickness, cancer, other health problems.
Okay, so now I'm starting to get why this is such a big deal. This isn't just some cool, science fact. This has real consequences for our tech, for human exploration. So what are scientists doing about it? I mean, are they just sitting around freaking out that space is scary?
Oh, no, not at all.
Okay.
This discovery has actually sparked a ton of new research.
Okay.
Scientists are poring over all this data from CIRRUB and other satellites, really trying to understand how these new radiation belts formed and why they stuck around so long.
It's like a cosmic detective story, right?
You could say that. They're looking for clues in the composition of the belts, the energy levels of the particles, the timing of the solar storm, everything.
And the ultimate goal is to, to make better predictive models.
Yeah.
So that we can be like, hey, the sun's about to, have a meltdown. Let's protect our stuff in space.
Exactly. If we can anticipate these events better, we can take steps to minimize the risks.
Yeah.
Maybe adjust satellite orbits, power down sensitive systems during the storm, or even delay launches until it's safe.
So it sounds like we really need to, step up our space weather forecasting game.
Big time. It requires investment in research, development of new technologies, and global collaboration, really.
Huh?
I mean, space weather affects everyone on Earth, right?
Right.
So it's a challenge that demands a unified response.
Okay, let's zoom out for a second. We talked about the science, the risks, the implications for tech and exploration. But what does this all mean? What's the big takeaway here?
I think the key takeaway is that Earth's magnetic environment is way more dynamic and complex than we ever realized.
Yeah, we kind of think of it as this constant protective bubble, but it's really constantly changing, responding to what the sun's doing.
Exactly.
And this event with these new radiation belts forming, it's like a big reminder that we still have so much to learn about how our planet interacts with the sun and how that affects us.
It's pretty humbling.
Yeah. I mean, we've got all this technology, all this scientific knowledge, but we're still at the mercy of these powerful, cosmic forces.
In a way, yes, but it's also incredibly exciting.
Right.
Each new discovery, even if it's a challenge, it pushes us to expand what we know and to come up with new solutions.
It's like the universe is just constantly throwing curveballs at us.
Keeps us on our toes.
To keep us on our toes. And speaking of curveballs, let's take a quick break. Okay. And when we come back, we'll dig even deeper into what this all means, what it means for space exploration, for technology, for the future. Don't go anywhere.
Okay, so we've kind of established that this whole new radiation belt thing, it's a pretty big deal, especially for anything we send up into space. But I want to get into the specifics. What kind of impact are we talking about here for, say, a satellite orbiting Earth?
Well, imagine you're a satellite
Okay.
happily beaming down TV signals from geostationary orbit. That's about 22,000 miles above Earth.
And that's kind of the sweet spot for communication satellite.
Right.
Because they stay fixed over one point on the planet, right?
Yeah.
But now there's this added layer of radiation to deal with.
So it's like a space obstacle course for our tech?
Pretty much, yeah.
Okay.
These high-energy protons and electrons can slam right into a satellite's electronics, cause all sorts of problems.
Like what?
Glitches, data corruption, even total system failure.
Oh, those are all bad.
Yeah, especially with how much we depend on these satellites.
Right. I mean, communication, navigation, entertainment, all of it.
Absolutely. And it's not just the immediate impact either.
Okay.
Even low levels of radiation exposure, over time, it can degrade the satellite's performance.
Oh, wow.
Shorten its lifespan. So this new radiation belt, it adds another layer of complexity to designing and actually operating spacecraft.
It's not just satellites we got to worry about, though, right?
No.
You mentioned human spaceflight before. What are the risks for astronauts, especially those going, past Earth's orbit?
That's a really important point. The radiation levels in this new belt, they're a significant risk to astronauts, especially for missions that go beyond low Earth orbit, where you have less protection from Earth's magnetic field.
So missions like that planned lunar base, that could be impacted.
Yeah, exactly. Astronauts on those missions would be exposed to way higher levels of radiation for a lot longer,
Okay.
really increasing their risk of, developing radiation sickness, cancer, a whole bunch of other health problems.
It sounds like we're entering a new era of space exploration where radiation's a much bigger concern.
Yeah, I think that's a good way to put it. We've always known about radiation being a hazard in space, but this discovery really highlights the need for much better shielding on spacecraft and better strategies to mitigate that radiation exposure during those long-duration missions.
So what are scientists and engineers doing to tackle these challenges? Are there any solutions in the works?
Oh, yeah, absolutely. There's a ton of really exciting research happening right now.
Okay, like what?
A lot of it's focused on developing these new materials for radiation shielding, optimizing spacecraft design, to
Okay.
minimize exposure, and even like exploring the possibility of using artificial magnetic fields
What?
to create these like protected zones for astronauts.
Wait, hold on. That sounds like sci-fi.
I know, right?
Creating a magnetic force field around a spacecraft.
Yeah, it sounds futuristic, but the concept itself is based on real science. If we could make a magnetic field around a spacecraft or a habitat strong enough, it could actually deflect those incoming radiation particles,
Really?
creating a safe haven for the astronauts.
Yeah, that'd be incredible.
Yeah.
But while those technologies are, being developed, what can we do right now to protect our, existing satellites and the astronauts that are currently up in space?
One of the best strategies is to improve our ability to predict these solar storms.
Yeah.
If we can forecast them more accurately, we can take steps to minimize the damage.
So like giving those satellites and astronauts a heads up to like batten down the hatches.
Exactly. With enough warning, we can adjust satellite orbits,
Okay.
avoid the most intense radiation, temporarily power down sensitive systems. We can even delay spacewalks
Right.
or other activities that would increase astronaut exposure.
So it sounds like accurate space weather forecasting, that's becoming more and more important for the future of space exploration and really our reliance on space technology.
Absolutely. It's like having a weather forecast here on Earth, right?
Right.
Knowing when a storm's coming allows us to prepare and kind of minimize how much it messes things up. And the same thing with space weather.
So what are some of the challenges then to improving space weather forecasting? Is it just a matter of having better instruments up in space, or is there more to it?
It's definitely a multifaceted challenge. We need more advanced instruments up in space, of course, to monitor the sun's activity
Okay.
and track those charged particles.
Like CRB and its fancy Reptile 2 instrument.
Exactly. But it's not just about getting more data.
Okay.
We also need to understand better the physics behind these solar storms and how they interact with Earth's magnetic field.
So we got to like refine our models, our algorithms, so that we can get like more accurate and more timely predictions.
Exactly.
It sounds like a pretty big job.
It is, but it's a challenge that scientists and engineers are working on. There's a lot of international collaborations going on, pooling resources and expertise,
Yeah.
trying to get better at predicting and mitigating the impact of space weather.
That's good to hear, because honestly, this whole conversation's made me realize like how much we take our space infrastructure for granted.
I know, right?
I mean, we rely on it for so much.
Yeah.
And now it suddenly feels a lot more vulnerable than I thought.
I think that's fair. We depend on space technology so much, it's easy to forget how fragile it all really is.
Yeah.
But the good news is we're more aware of those risks now,
Right.
and we're taking steps to address them.
So even though this new radiation belt, it's a serious challenge, it's also a chance to learn, to innovate.
Absolutely.
Like push the boundaries of what we know and what we can do technologically.
Every challenge is an opportunity.
Right.
And this one is pushing us to become better caretakers of our space environment.
Yeah.
To develop these new technologies that will help us explore space, but also, benefit our lives back here on Earth.
Yeah. Well, you've definitely given us a lot to think about. This whole new radiation belt thing, it really is a reminder that space is dynamic
Mm.
and sometimes unpredictable, but
But
it's also a testament to human ingenuity and our drive to explore and understand the universe.
I totally agree. Who knows what other surprises are out there waiting for us?
Speaking of surprises, we've got one more fascinating twist to uncover in this whole story.
Oh, I'm intrigued. What is it?
Well, it turns out that this discovery, it's raised some really interesting questions about the very nature of Earth's magnetic field.
Hmm.
Stick with us, we'll dive into that and explore what it all means when we come back.
All right, so before the break, you were hinting at this twist in the whole radiation belt story. Something about Earth's magnetic field. You really got me curious.
Well, one of the things that's really got people thinking is how this discovery changes what we thought about Earth's magnetic field. Like how stable it is, how predictable it is.
Yeah, we always think of it as this like solid shield, protecting us from the
Yeah.
sun, but now we're seeing that it's a lot more, I don't know, changeable than we thought.
Exactly. And this event, it's shown us that these really intense solar storms, they can have a much bigger impact on Earth's magnetic field than we ever realized. So it's not just about these, temporary radiation belts popping up and disappearing. It's about these events actually changing our planet's magnetic field, like in a more fundamental way, right?
Yeah, and that brings up a lot of questions.
Like what?
Could these changes, could they become permanent,
Mm.
after a while? And how would that affect our planet, our ability to explore space?
Yeah, that's pretty mind-blowing to think about. It's like our planet's magnetic field is having a midlife crisis or something. But seriously, what are some of the potential implications of these changes?
Well, one of the biggest worries is what it could do to our technology,
Yeah.
both in space and here on Earth.
Okay.
A weaker magnetic field, or one that's less stable, that could leave us much more vulnerable to these solar storms,
Yeah.
which can, disrupt power grids, damage satellites, mess with communication systems.
And we've already seen how much we rely on those systems. I mean, for everything.
Mhm.
GPS, financial stuff, just talking to each other.
Absolutely. And as we depend more and more on space technology, the risks just keep getting bigger.
So this isn't just like a theoretical thing.
Yeah.
This has real consequences, for how we live our lives.
It really does. And it really shows how important it is to keep researching Earth's magnetic field and how it interacts with the sun.
And to build tougher technology, right?
Yes, exactly. We need to be thinking about how to make our stuff, our infrastructure, able to withstand these space weather events,
Mhm.
both in the way it's designed and how we actually use it.
So this discovery, it's kind of a wake-up call, isn't it? It's a reminder that we live on this, dynamic planet
Yeah,
that's always interacting with space.
I agree with that. And it reminds us that we still have so much to learn about the forces at work in our solar system and how they shape our world.
It's humbling, but it's also pretty exciting.
It is. It's a call to explore, to innovate, to adapt to whatever challenges the universe throws at us.
So if we were to leave our listeners with one final thought to chew on, what would it be?
I think if this whole event has taught us anything, it's that we can't just assume that Earth's magnetic fields will always be there protecting us. It's this powerful force, this dynamic force
Yeah.
that really is essential to protecting our planet and letting us explore space.
Right.
We have to keep studying it, keep understanding it, and really respect its power.
Some very wise words. And on that note, we've reached the end of our deep dive into Earth's new radiation belt. We covered a lot today, from the science behind it to what it means for technology, human exploration, even the future of our planet. I hope you enjoyed it as much as we did. And until next time, stay curious and keep looking up.